you're in. I just want to make one quick announcement for Fort Lewis. We have a session on Navajo Nation water rights on campus. Some folks from Navajo Nation's hydrology unit are coming out to talk about some of the recent policy and Supreme Court settlements that have happened and what that means for people. It's going to be over in Burnt Hall right after this. So it starts at 6. There's going to be some food and refreshments there. So if you're just interested, go grab some food, meet some people, hang out, listen for a little bit. Or if you need a makeup for one of our classes, you're welcome to write a summary on that. But before that, for the next 55 minutes or so, we have Dr. Andrew Todd from the US EPA Water Quality Section, a life scientist who's been working in this field in many different capacities for a lot of years, to share about his career and work that he's doing and where he's been and what's happening next. So thank you so much for joining us. Really appreciate it.
Yeah.
And that clicker should be good for you too if you want it.
Oh, it's okay.
But you don't need to use it.
Give it a roll. Hey guys, I'm Andrew Todd, and I'm super informal. So if you have a question in mind as I'm going through, or something really jumps out at you and you want to talk about it real quick, just feel free to interrupt me. You're not gonna offend me. Can everyone hear me online? Roberts, can you hear me?
Yes, we can hear you.
All right, sounds good. So as Katie said, I'm going to go through sort of my career in water quality so far. I've gone in a lot of different directions. I've seen a lot of the different ways to get involved in not just water quality, but water in general throughout my career. And so I think I've got somewhat unique perspective on a lot of the different areas you can immerse yourself in. But I'm going to go way back to the very beginning. So this is me as a kid. Those are brook trout, so don't be offended. They're non-native to the state of Colorado, so it's okay to eat them. So I grew up in Denver. I learned to love fish on fishing trips with my dad. He is a physician, and he had a conference in Aspen every year. And so he would take us up there, and we would fish, among other things. And there's a creek called Lincoln Creek that I grew up fishing, and it's been in the news recently for some water quality issues of its own. But my whole fishing life is built on a lie, because my dad would take us to Lincoln Creek, and he would call Parks and Wildlife ahead of time to figure out where they were stocking. And so one of my favorite trips where I caught a lot of fish and figured out I was pretty good at fishing was when the stocking truck, the lever had jammed, and it had dumped the entire truckload of rainbow trout in one spot. And the guy told my dad where it was, so he took me and my brothers and younger sister there. So that's where I learned to love fishing. It was all a big, huge lie. But then as a teenager, I really learned to love the outdoors. I took a couple of, wasn't outward bound, but it was that same sort of style outdoor courses in the Sangre de Cristo Mountains. We went up Humboldt and Crestone Needle as a part of those trips. And I now actually have a cabin down on the Sangre de Cristos on the same trail that went up to those 14ers that I ventured around when I was a kid. I went to Manual High School, an inner city high school in Denver, where I got super interested in biology. And I got to give a shout out to Miss Hargis. I don't see her on the Zoom right now, but I think it's really important to recognize those people that got you interested in learning along the way. And Ms. Hargis was certainly one of them. So then I went to college. I went to Williams College on the East Coast. I thought I was going to be a veterinarian. So I studied pre-med, including biology, chemistry, physics. I didn't become a veterinarian. I just married one instead, which has all the benefits of being a veterinarian without actually going to vet school. I played a lot of lacrosse. I didn't explore the Berkshire Mountains, which are actually really spectacular, a ton of trails, as much as I would have. So that's sort of a push on you guys to get out and enjoy. I ran some trails around here earlier today, and so if you're not getting outside and exploring the area around campus, I would definitely do that because I regret not getting out as much in the Berkshires. But importantly, I graduated with no idea of what I wanted to be when I grew up, and I'm making progress, I think, but still not 100% sure. So my first environmental job, I worked for a private consulting firm called Aqua Sierra, which is out of Denver. A friend of mine from high school got me this job. We did a number of things. We designed aeration systems, which basically oxygenate ponds so that fish can survive in them. But I also drove to Arkansas to pick up warm water fish to bring back to stock in Denver. So whenever I write my autobiography, if I'm ever worthy of it, I'm going to call it Hauling Bass, because that was one of my first jobs from Arkansas to Denver. But I also learned the basics of lake and pond science and management. And that got me really interested. So I went to graduate school and I went to CU. Coach Prime wasn't there at the time, but I think he came there because I was an alum. And I don't know if you have been watching CU, but it's a lot of fun to watch these days. So I decided to go back and get more educated, and I stuck around for, I think it was 5.5 years at CU, where I got a master's and PhD degrees in environmental engineering. Environmental engineering, I discovered, is not what I thought it was, which I wanted to be engineering in the environment. It's more wastewater treatment, water treatment. But fortunately, I had Dr. McKnight, Diane McKnight, who allowed me to make environmental engineering what I thought it should be, with classes like applied stream ecology. I also took fluvial geomorphology as a part of grad school. And then I did my dissertation on the impact of acid rock drainage on mountain stream ecosystems. And the specific ecosystem was the Snake River ecosystem near Keystone. And I'm going to talk a little bit about acid rock drainage moving forward here. Second real environmental job, I was a contaminants biologist for Fish and Wildlife Service out at Rocky Flats, which is now, as you can see in the picture, a national wildlife refuge. It wasn't at the time. It was a place that made triggers for nuclear bombs. And so in the transition from being a weapons facility to a wildlife refuge, my job was essentially to wander around the buffer zone, which was around where all the plutonium, americium were, and look for evidence of disturbance to see if there was any pollution in the part of the property that was going to become the wildlife refuge. But I also got to do fun stuff like track, chase, and collar deer fawns out of Rocky Mountain Arsenal, which is another weapons plant turned wildlife refuge. I think it was the model for what they wanted Rocky Flats to become. So that was a lot of fun running around tackling fawns. They're a lot faster than you think they ought to be. You've got about 3 days before they can outrun you. But that was a fun part of my early career. And one of the other things we did, one of the preferred uses at wildlife refuges, if possible, is hunting. And so one of the studies we did out there was evaluate the risk of hunting deer and elk because of the residual plutonium in the soils. And we determined that, so what we did is they were also, Parks and Wildlife was doing a chronic wasting disease study. And so they took the heads. We took everything else from these deer, processed it, looked for plutonium, americium, uranium, and we determined you had to eat the entire herd of deer every year for 75 years to increase your cancer risk more than 1 in a million. And so we determined hunting would be a safe use of the lands at Rocky Flats. I don't think they allow hunting currently because of its proximity to some residential areas. Next job, I worked for Trout Unlimited. I was an aquatic specialist. One of the things we did, we established in-stream flow protections for small trout streams. But one of the bigger things we did was help build the scientific case for lawyers the fights that TU's lawyers would pick over water and keeping that water in streams. And this acronym here, the PAWSD, is Pagosa Area Water and Sanitation District. When I was there, and this is now, boy, almost 20 years ago, Pagosa was trying to perfect one of its water rights and make this massive reservoir. I think it was called Dry Gulch. And so they did this population forecasting out 50 years into the future. I can't remember the specifics, but it had Pagosa being the size of Denver in like 50 years. And I was like, that's not happening. So my job was to break the spreadsheet that Pagosa Area Water and Sanitation District built. And ultimately, they did not get to develop the water as they wanted to. And so that water remained in the San Juan through there, which is great. But then one of the other things I did was testify in front of state boards for regulations that are protective of those aquatic resources. And that includes the Colorado Water Conservation Board, as well as the Colorado Water Quality Control Commission, where the primary thing I worked on was to establish protective water temperature standards for the state of Colorado. And then I moved to the USGS, where I was a research biologist for a decade. And I did a lot of different studies while being a research biologist. I'll talk a little bit later about one of those. But I was really studying the impact of a lot of different stressors on cold water fisheries in the Western US, including legacy mining, which was sort of a build on for my dissertation, but also these major water projects and the havoc they can wreak on stream ecosystems, as well as climate change, which we all know is a big one, particularly for cold water fisheries. And this is me. This was a government issued trailer, and this is me sitting outside of it, probably drinking a beer if I know myself. So back to the Colorado Water Quality Control Commission. Either I did a really good job or someone was punishing me. I was appointed by the governor to serve as a commissioner. It's a board of 9 regular citizens who come together from different perspectives to consider and make water quality policy for the state of Colorado. And much to my surprise, one of my co-commissioners for about 6 years, I think, is on the Zoom call right now watching me. So he's probably just waiting for me to trip up, and then he's gonna tell me how I messed everything up. But I ended up serving 3 terms, 9 years, and that included 2 years as the chair. But my favorite commissioner during that time was Robert Sakata, who's on the phone right now. So after, and that was all volunteers. So that was in addition, that was co-timed with my time at the USGS. So I had to go through like an ethics review process with the USGS to make sure I wasn't stepping on myself with what I was doing with the state. But that was all volunteer. And so I think we got a check for like $100 for every meeting. But it was a lot of work. We would get huge boxes of paper to review and then make decisions on a month later. And it was a really challenging role for me personally. But so after working for Trout Unlimited for a bit, I went to the after USGS, where I was a research biologist, I went to the US EPA, where I was an aquatic toxicologist for 4 years. And that's where I really got to know this area pretty well. My job was to predict the ecological benefits of investments in environmental cleanup, including the Superfund program. And I was involved with several mining sites, including the Bonita Peak Mining District, which I'm going to talk a little bit more about later, but that's up in Silverton, and then the Animas River as it extends down here to Durango. And I completed the aquatic ecological risk assessment. I was the lead on the EPA side for getting that to the finish line and evaluating the current risk, and then using that as a tool to evaluate, well, where should we target of all these mine sites around the the Silverton area, where should we focus our efforts? Because we can't do it all. So that brings me to my current job, or the current job is life scientist. I was a section supervisor. I supervised the water quality section for 4 years, and Region 8 is our region. We oversee 6 states, so it's Colorado, Wyoming, Utah, the Dakotas, and Montana. And they all have bodies like the Colorado Water Quality Control Commission, and EPA runs oversight on those. We have to approve what they approve for it to become law under the Clean Water Act. And so my job was as the supervisor for those six states. My staff supervised and oversaw those 6 states and 27 tribes. I did that for 4 years and decided I'm not management material, and I demoted myself back in May, and I'm confident that it's one of the best things I've ever done. I'm happier. Not that the people on my team were outstanding. It's just there's a lot of with the huge federal bureaucracy. There's a lot more administrative stuff than I have the stomach for most days. So I am now a life scientist, and so I'm now the lead for water quality standards for North and South Dakota. I also have 2 tribes, and I'm specializing in the water quality nexus with the Endangered Species Act. And then I'm always into extracurricular stuff. So since I am not volunteering on the Water Quality Control Commission anymore, I have all this free time. So I started a nonprofit about 10 years ago called Running Rivers. I'm the founder and its executive director. And what we do is we organize a series of trail running, fly fishing, craft beer races that raise money for native trout conservation projects. And we get that work done through partnerships with organizations like National Park Service, Colorado Parks and Wildlife. And so that's my free time activity there. So that's why it's level 8+. Level 9, who knows? We're in sort of an uncertain time in the federal government, as you may have been reading. So the giant, I can't tell if that question mark is happy or sad, but it's the great unknown for me right now. So unless there's any questions on specifics of where I've been in my life, I can jump into some of the key water quality issues that I see facing Colorado now and moving forward. Any questions? Okay.
Who's been your favorite so far that you experienced?
Oh, that's like picking kids, man.
Yes.
The nonprofit that I created has been a lot of fun because it allows me to be super creative. I really liked working for the U.S. Fish and Wildlife Service because there were no expectations. I was literally tackling fawns and collaring them, so that was kind of fun. I will say across the board, I've loved the people I've had the opportunity to work with, and I think that's I don't think it is a bad thing to move around and do new things, because you don't lose what you were doing before. All those people, like the woman who was my mentor at the Rocky Mountain Arsenal in that deer study, she is a liaison for Fish and Wildlife to EPA now, and so we're good friends. We've been friends for 20 years, and so I will say that about the water community and the environmental community in general, environmental science community, is that it's a pretty tight group. So even when you leave, you're never fully free from your past duties. People still ask me questions about plants. They also ask me questions about like whales, because when you're an environmental scientist, they think you know everything about the environment. And like, dude, I've lived in a landlocked state my whole life. Don't know anything about whales. So don't ask any whale questions. Any other questions? All right, so one of the big issues that faces Colorado and will, I think, it's actually there are signs that our past pollution and the contribution to some of our water quality problems is getting worse with climate change. But mining certainly is an issue for Colorado and for states around the West. So basically, how does acid rock drainage form? We've got these natural geologic formations that have metal-rich and acid-forming minerals. And so then the miners came in, they took it out of the ground, they smashed it up and left it on the surface, so they increased the surface area, which is now available to be weathered. So you've got increased surface area, which can react with water and oxygen to produce acid, which further leaches metals that can be toxic to aquatic life. And we have an estimated 23,000 abandoned mines in Colorado. Not all are the same severity. You know, if you're driving up I-70 to go ski, you can see the glory holes. I think those count in this 23,000. They're not all big contributors to water quality pollution, but that's a pretty big number just in Colorado. And it speaks to our mining history, but also the challenges we face moving forward. And so this is what acid mine drainage can look like. This is the Pennsylvania mine and the draining adit coming out of it. It's much different now because there's been a lot of reclamation work done on the Pennsylvania mine. This was back during my dissertation. These photos are from. You see the orange color, that's iron hydroxide precipitating out. And then the white there, I know it looks kind of clear, but that's white. That's aluminum hydroxides precipitating out, both of which are not very good for aquatic life. And you can see right there, you've got the clean stream and the iron coming in on the side there, and where they mix, that's where it turns to this white color because you've got an increase in pH. The aluminum precipitates out at a higher pH. So it's kind of a cool thing to see, but not if you're a fish or a bug. So the big mining area in your backyard down here in Durango is the Bonita Peak Mining District. It was mined from the late 1800s into the late 1900s, and there are hundreds of mines spread throughout the Bonita Peak Mining District, and all those little black dots. So for right in the center is Silverton. All those little black dots are mines spread out around the Bonita Peak Mining District. And as I mentioned before, it's the mining and milling process that increases the surface area and makes the area more reactive for producing acid rock drainage. And it was added to the national priorities list, so to the Superfund list in 2016, but not all, however many 100, 200 sites out there. It was defined as these 48 sites defined the Bonita Peak Mining District scope. So how do you go about evaluating a massive watershed like this? So this goes all the way up to Cinnamon Pass and then all the way up Mineral Creek. So this is a huge watershed. And then it continues all the way down to Durango as well. So what we tried to do was break it up into different pieces to understand the chemistry and the biology in each of these small pieces, so that we could figure out where we could make the most progress within cleanup. So I think there were, how many? 20 exposure units, we call them. And within each of those exposure units, as a part of this risk assessment, we looked at all sorts of different things. We looked at surface water chemistry, sediment chemistry, pore water, so that's the water in the sediments underneath the flowing water. We looked at fisheries information. We went out there and electrofished those orange creeks and said, are there fish here? In most cases, the answer was no, but we did find fish in a number of places, some which surprised me and surprised some of the people that have lived in the Silverton area for a very long time. We looked at benthic macroinvertebrates. These are the bugs that live in the creek and feed the trout. We've got an expert in the room on benthic macroinvertebrates and Scott. So if you've got any macroinvertebrate questions, he's your guy. We did toxicology. We took water and sediment back from the field to the lab and exposed test organisms to different dilutions of the water from the field to see, okay, we know 100% site water is toxic. What about 50%? What about 25%? What about 12.5%? And then we can identify how far off we are from having water that's survivable by those organisms that you're testing in the lab. And then we also looked at fish habitat suitability information. So we've got a lot of areas up in that Silverton area that are dead. They currently don't have fish, but it's also a high alpine environment, and so you don't want to spend millions and millions of dollars cleaning up the site and saying, good, our water quality is good, only for it to have crappy habitat and not be suitable habitat for that fishery to come back anyway. So it doesn't mean that you're writing areas off for cleanup because it doesn't have good fish habitat. It's just one of the factors that we looked at. Like if we got water quality to a point where fish could survive, would we expect the fish to live here in absence of that water quality problem? And we tried to be spatially comprehensive in all of these things that we were measuring. So these were the locations for our 2016 surface water sampling. So it was a huge effort. Same went with, we were looking at the spring and in the fall. Not all sites were sampleable during runoff because, the creeks are cranking at that time. It's not safe to get in there. But you want to evaluate what water chemistry looks like in different seasons because, the fish have to live there year round. So you really need to understand what that variability in chemistry looks like over the course of the year and across this huge landscape. So it was a lot of sampling. You asked what was a fun part of my job. This was fun, driving around the Bonita Peak Mining District in federal vehicles collecting water quality samples. That was a good time. At the end of it all, we integrated that information and came up with these ribbon maps. This is just the fish present absent map, just to show you. They all showed similar things. Where the fish are absent, the bug scores were usually pretty bad. Chemistry was pretty bad. And so as the EPA and with input from the community, we identified 4 priority reaches where we expect that cleanup work in the Bonita Peak Mining District can have a beneficial impact. This is the South Fork of Mineral Creek. It's already, as you see, got a fishery in there, but there are a couple mines up in the headwaters that if those were cleaned up, that would make it even better for that fishery. You've got the Upper Animus, which is sort of marginal water quality, has an existing fishery of brook trout. The question was, could we improve water quality enough for it to be habitat for more metal sensitive trout species like cutthroat trout, which would have been the native fish to this watershed. And then this one up here, that's the main stem of Mineral Creek above Middle Fork of Mineral Creek. That is a location where all historical sampling in there suggests that did not have fish in it. And that's one where I was shocking up and these brook trout rolled over and I was like, you gotta be kidding me. So I went back the next year, shocked that brook trout were still there. And so in large part due to the voluntary cleanups that have been done by the local stakeholder group up there over the years leading up to this, the water quality improved enough in that stretch that brook trout can now inhabit it, where historically it was devoid of fish. So that's sort of an exciting development that, shows what the kind of impact we can have if we focus on cleaning up some of these mines. And then that star, it should be way down on the floor, is a reach down just above Durango. So that's well downstream. Water quality improves, but there still is some residual metal contamination in the Animas River down near town, and so that's the final reach that we're evaluating for improvement with these, and sort of the integrator of all the cleanup projects that will occur in the Bonita Peak Mining District. So what other stressors do we have? Any guesses on what this one is? Looks like toilet paper. That ruler in there is, I put that there. That's to show how deep that sediment was. That's roads sand coming in. And so, you know, we've got all these great opportunities up in the mountains for skiing, snowboarding, fishing, trail running. But in order to get everyone up there, you got to maintain these highways year round. And that involves sanding and salting. And every year, this time of year before, I'm watching the news in Denver, and it used to be a woman named Stacy Stegman on the news who would talk about, with CDOT, who would talk about how we've got more mag chloride than ever that we're going to put out on the roads. And I would just cringe because all of that stuff that they put on the roads ends up in the watersheds that drain those roads, and those can have an impact on the organisms that live there. And so unless properly mitigated, they can become contaminants, both physical and chemical, in local streams. So I've got some examples here. We've got Straight Creek, which is I-70 coming down from Eisenhower Tunnel down to Silverthorne. That historically had a cut-through trout population in it that's now gone because of the road salt and sand. Black Gore Creek, that's on Vail Pass, which obviously we need to keep open to get all the skiers over to Vail. But they've implemented some mitigation measures to try to drop a lot of that sediment out so that it doesn't go all the way down Gore Creek. And so that's this Black Gore Creek is where the mitigation measures have come in and have been successful to a large degree. Same with the Upper Fraser, which is the road over to Winter Park. And so, you know, these mitigation measures are important, but, you know, we need to consider as we're thinking about how we're going to keep these roads open, what the potential consequences in the environment are. And then we've got some other scary emerging contaminants like 6-PPD and 6-PPD quinone. These are tire additives that have been shown to be a water quality stressor for salmon in the Pacific Northwest. It's not really known how big of a threat this is to some of the other salmonids, including the trout species present in Colorado. So this is an area of active research, but kind of scary to think that the tires might be picking these pollutants in as well. Okay, so more mountain population. This is a population percent change by county from 2010 to 2020. The yellows transitioning to red are all increases, and the blues are all decreases. You can see in the mountains, we've got a lot of populations that are gaining in population, or a lot of counties that are gaining in population, including Custer County, which is where my cabin is. But we don't have a lot of people there, so maybe me moving there is part of that increase. But where you've got more population coming in, you've got more mountain waste. And so all these new people coming in are creating waste that needs to go to a wastewater treatment facility, and then the discharge from that wastewater treatment facility is going into these receiving waters like Gore Creek and the Eagle River. And so you've got to start to worry about things like ammonia, metals, like copper. Anyone know why there's copper in wastewater? Any thoughts? Is copper piping in your house? So a lot of these old houses, they're weathering essentially as the water goes through there over time. And so there's copper in the wastewater. Nutrients are a big one. Excess nitrogen and phosphorus can lead to eutrophication. We've got pathogens. And then another one that you don't think about, these mountain watersheds, water temperature is a big thing. Trout operate within a very narrow thermal window, and wastewater, when it comes out, even after treatment, is often warmer than the receiving water, and that can have an impact on those fisheries in mountain ecosystems. And then, of course, we've got these emerging contaminants, which we're not 100% sure what the ecological consequences of pumping pharmaceuticals, hormones, caffeine, all this stuff that largely goes untreated through the water quality treatment process. What does that do? And we've got some clues. This was a study from back, I think in the 2000s, in the South Platte River below major wastewater treatment plant. And you can see the study results show it upstream of the sewage plant, you've got 85 total white suckers, roughly half are female, half are male. Downstream of the sewage plant, you had 143 fish, 117 of which were female, 12 were male, and 14 were intersex fish. So they had tissues of both. And so what does that mean from an ecological context? How far does that effect translate downstream? These are all questions that we're going to struggle with as we introduce pollution into new watersheds. Of course, we've got the energy economy. We've got oil and gas development, which is largely a infrastructure issue. So you build all these roads, transmission lines, that disrupts the ground. You can have non-point source pollution back to the sediment getting into the water bodies. That could become a big problem. Coal bed methane, oil shale, both either produce water. Coal bed methane, you've got this methane down in the underground coal seams. When you're pumping the methane out, you're also pumping the water out. You got to do something with that water. Oil shale, you need water for that development. Both of those result in these produced waters. And so you've got large amounts of produced water of varying quality extracted during these processes. And what are you going to do with it? Sometimes it's re-injected. Sometimes if it's good enough quality, it's being given to cattle, to water cattle. Sometimes it's released into the environment. And so these are all water quality issues that result from energy development. Increased demand for water. So we've got major water projects trying to provide water for those counties that are growing. Those houses not just produce wastewater, they need water coming in. So where's that water coming from? Often it's from these mountain streams. And so we can get things like loss of flushing flows, loss of dilution flows, water temperature increases, less water in a system can warm up quicker. And then I just noted this recent federal court decision, Denver Water, their Gross Reservoir Expansion project. It says Gross Reservoir. I meant expansion. That was challenged by a number of environmental groups, and recently there was a court decision saying that they had violated some NEPA actions, and so they now need to revisit what they're going to do, even though this expansion project is well into construction, because they didn't check all the boxes they needed to as a part of NEPA. Now they're faced with what do we do now? So they're going back to the table with some of these environmental groups to figure out what can be done now. So you guys probably have heard this already. Water quality and water quantity are of different, the laws that surround them are of different ages. So water quantity law is much older. And as a result, water quantity law kind of sometimes butts up against it. And you can't, even though less water in a stream can create or exacerbate pollution problems, like with the Water Quality Control Commission, we can't mandate that water be left in a stream to dilute and mitigate water quality problems. And so, there's sort of this butting of heads with water quality, water quantity, and water quality sometimes that can be challenging in terms of thinking through solutions for these water quality issues. Okay, so climate change and how that could impact cold water ecosystems. There's a lot of ways. All of these things that are anticipated with a changing climate can have impacts for the lakes and streams that we love so much in Colorado. And I'm gonna talk through a real quick case study, as long as I have enough time with you. So this was some of the work I did back at the US Geological Survey, looking at the potential influence of a changing climate on the persistence of the Rio Grande cutthroat trout. Rio Grande cutthroat trout is native to southern Colorado, the San Luis Valley, and northern New Mexico. And so some of the questions we were asking: will we lose cold water fisheries if and when it gets hotter? So these histograms are from temperature loggers that we put out in streams. On the upper three graphs, we have the maximum, so like an acute temperature threshold that the state measures, and then at the bottom is a chronic temperature threshold. And the threshold itself, so these are all in-stream measurements. So this is what we're seeing. The black bars are what are core conservation populations for the Rio Grande cutthroat trout. So we went out and we put out temperature loggers for 3 years in those, and we calculated these summary statistics, and we compared them to the water quality standards, which were developed to protect these cold water fish. Oh, wait, I went backwards. So you can see already a number of these conservation populations where these fish are supposed to be safe from or safe as Rio Grande cutthroat trout are already pushing those and exceeding those temperature thresholds that were designed to be protected for them. And so now you can just imagine if those, with a warming climate, if those histograms shift to the right as each of these warms, assuming each of them warms, and that's an assumption, but any warming in those, you'll see somewhat of a shift to the right, which will push more of those streams into that too warm category for these fisheries. And what did that look like on the ground? So this little graph here with the blue and red, the dashed lines are what the regulated community in Colorado lovingly calls the top hat, because we have a seasonal water temperature standard. So in the wintertime, you've got that lower red and blue dashed line, and then it jumps up in the summer to the top of the top hat and then comes back down. But what I want you to look at is the blue lines, or I'm sorry, the squiggly, the graph data itself, which is the measured water temperature. And in this creek, the blue graph data is exceeding that top hat, as is the red. So they're going above those thresholds. This is one of those that was to the right on the histogram. And so we're exceeding the water quality standards. Over in the bottom right there, that's what the creek looked like. And what you can see up in the top right corner is not a trout. That's a sucker, which is more warm tolerant. And so that's what I expect when these streams start to warm up, is that you'll see more warm water fish species doing better, and the cold water fish species losing out. And this has the potential to undermine one of the restoration strategies for native fish, which is to have these big, they're called metapopulations. So you've got all these tributaries, which may be cold enough to into the future to continue to hold trout. But if the main stem is getting too warm, and again, back to those graphs, if we look at Miners Creek, which is way up in the headwaters, our blue and red graph data falls below the top hat. So it's not pushing up against those thermal thresholds. Down here in lower Carnero Creek, which is the main stem that connects them all, you can see again, we're exceeding those thresholds. And so we might have the expectation that becomes thermally unsuitable for those fish. And so no longer acts as a connector for those tributaries. And so those tributaries become isolated. And that's not good if you're trying to get genetic mixing between those tributaries. So those tributaries become increasingly isolated the warmer that main stem gets. So we talked about what if it gets hotter, what if it gets drier? On the left here, we've got the Palmer Hydrologic Drought Index, which is just a way of summarizing how dry a particular year was. And 2003 to 2012 over there on the right side of that graph was when the study was done. So a drier time. And on the right is the histograms of stream flow in each of those streams for 2010, 2011, and 2012. And what you can see is the overwhelming majority of flows in those streams has base flows less than 1 CFS, which is not a lot of water. So the margin for error, if in we don't know whether the future with climate change, that's the less certain of the two. We know it's going to get hotter. We don't know if it's going to get wetter or drier. It'll probably be some combination of those two with more extreme events. But if it gets drier, we don't have a lot of margin for error because so many of these, like that far left bar on each of those histograms is half a CFS or less. And so that's not very much water in these creeks that are conservation populations for this fish. And this just shows that this is one of those that was in the very low base flow category. And by very low, this photo shows that meant 0. This was at one of the locations where we had our temperature logger and the Rio Grande cutthroat trout. That's a conservation population for that fish species right there, and it's totally dry. The final scary thing with climate change is more and more intense wildfires. This is the Medno Creek drainage, which is Great Sand Dunes. This was a fire back in 2010. You can see the fisheries data here. So this is for station 6 there. The red indicates the burn intensity of that fire. So it burned a bunch of the watershed, but importantly, not the whole watershed. The top of the watershed got far less burned. But still, right after the fire, you saw a decrease in density of fish from almost 500 to just under 200 fish per mile. So an immediate effect. But the good thing about this burn was the fish were in a big enough watershed that because the watershed didn't burn in its entirety, the creek can repopulate from fish coming up from that upper unburned area once habitat stabilizes and becomes suitable down in that heavy burn area. So the intensity, severity really matters with these wildfires for how it impacts the native fisheries. So just to sort of summarize, and then I can take questions on whatever you guys want. Some lessons I've learned along the way. Lesson number 1, cutthroat trout are super awesome. That's at a lake called Lily Lake, which is in the southern Sangre de Cristos. You have to work hard to get to a lot of these places, but it's really worth it. They're a spectacular organism, and that's sort of the why I do all this stuff, is to keep fish like that on the planet. But things I've learned: try lots of different things. Obviously, I've done that. Work hard at whatever you do. Be authentic. That's big for me, is to be yourself and not, which is why being in the federal government has been a challenge at times, a big bureaucracy. It's sometimes hard to be yourself, but that's one that I would push on anybody, is to be authentically who you are. Swing for the fences, aim big, think big. We got big problems, obviously, so we're going to need big solutions. So the bigger you think, the more likely you're going to be to help solve some of these problems. And also think creatively. Some of the solutions might not be what we've tried already. Seek out great mentors. I think this is a huge one. People that can support you in thinking creatively and swinging for the fences, but also there's a lot of really smart people out there that you can learn from and who are willing to teach. So I think just reaching out, if you see someone who's doing what you think you want to be doing, just reach out to them and touch base. You'd be surprised. They may want to help out. But also educate the people around you as you learn more about stuff like this and the challenges out there, environmental challenges out in the world, most people around you aren't going to know about them. And so the more you can educate, the more these issues can be elevated and become priorities for us as a population. Try not to get overwhelmed. There's a lot in environmental science that will feel overwhelming and feel disheartening. So try not to. I said try, not don't get overwhelmed, because it's impossible. Sometimes you're going to get overwhelmed. And ask for help along the way. No one can tackle these problems on their own, so definitely reach out for help. But most importantly, never give up, because like that cutthroat is too important to give up and just kind of write off. And so with that, I guess I can take any questions about any of the things we covered. From online too. If you, I'll watch and see if any hands are raised. But
Questions from the room?
yeah,
I said never give up. Just curious, did you throw that trout back?
should I throw that trout back?
Oh, the other one.
Oh, I throw all trout back. Yeah, well, except brook trout. Sometimes I'll eat a brook trout because they're not. They're part of the problem for native fish. So sometimes, depending on where I am, I'll eat a brook trout. Yeah, most of my angling is catching, that's for sure. Yeah, go ahead.
What are some of the management strategies to get or to help with salt on top of roads? Like, do you block in the roads, or do you?
The salt part is harder because it gets dissolved and then moves into the stream. So the road sand, I think, is easier to manage. I think when it comes to like some of the things that are being considered, are there alternatives to the traditional mag chlorides that are less impactful to the environment, and doing research on things like that? Can we solve the issue, which is to keep roads ice free without pouring? And also it's like all non-point source pollution, like fertilizer. Can you apply it in quantities that are going to get the job done, but not in excess quantities? Which is why I cringe every time CDOT says like, we got more than ever this year, we're going to really get out there and hammer it. But unless so it's I think it's tough with the liquid chemicals that they throw down to keep it out. Unless you have any thoughts. Not that I'm aware of, at least.
Are there any questions from CSU?
Yes. I have a question about, so obviously, as the rock drain aquatic life, but I don't know if you can hear me, but can you guys hear the question?
I think we can now.
Okay, speak loud.
You can hear you, Karen. It's hard to hear others.
Okay. Basically, has he seen like fishers and recreators respond to these changes in water quality as well? Let me see if I phrase this correctly. Have you seen fishers and recreationalists respond to the issues in water quality with acid mine drainage as well, kind of in response to the water quality issues? Is that okay? Yeah. So
have we seen a response in the fishing community with acid rock drainage? Is that the question? I think, I guess my experience out in the field would be no. I've been out fishing or out working on some of these acid rock drainage impacted streams that are like bright orange, and I've seen people fishing them. And depending on how decked out they are, I'll tell them I caught something under the bank real quick, even though it's totally dead. But that's one of the things I've been trying to do with the nonprofit, is to better educate anglers about native fish issues, but also I think a lot of the fishing population is just out there to catch big fish, huge fish, and isn't really interested in the bigger environmental context of those fish. And so by creating events to help educate people about the environmental context of fishing, I think it's at least my way to try to educate better. But I think some anglers are knowledgeable and thoughtful about that because you can only go to so many creeks that are dead before you get frustrated and start doing some research. So did that answer your question?
Yes, thank you.
Yeah.
We have another question too.
Okay.
Has your passion for the outdoors and fishing and running helped you land any jobs? Or how important has that been getting where you have in your career?
Has your passion for the outdoors and fishing and running helped you to get any jobs, or how has that influenced your ability to get to work what you're doing right now?
I think probably. I don't know. We could poll some of the people that have hired me, but I think being knowledgeable and passionate about whatever you're trying to get into is it can't hurt. And I think being dynamic and not one dimensional is important too, because if you've got a breadth of things you can point to that you've done because each job is going to be unique. And so the more diversity you have in what you've done, the more likely it is that you're going to be a good fit for whatever job you're applying for. So I always push people who ask me my advice to try to not be afraid of taking jobs, as long as you're taking jobs that advance you in sort of the right direction and give you more breadth. I think you're probably doing a good thing.
With your, it seems like the early part of your career was focused on Colorado and sort of understanding environmental and water quality issues in Colorado, and then you've expanded geographically. And for example, it looks like you're working in the Dakotas now. Has that been challenging to take what you've learned and extrapolate to new geography?
Yeah, it has, particularly on the fisheries front, where high mountain ecosystems are sort of by design very not very biodiverse. And then you get into the Dakotas where you've got all your small bodied warm water fish, and it's like I have no idea what that is. A lot of the stressors are different too, I think, and the political context of those different environments can be different too. So, but the skills are the same. So I think you can translate the skills as long as you're willing to, think of outside the box and not say that's not a trout. I don't know what to do now. The internet is a wonderful place, and there's a lot of good literature out there to draw from to translate what you do know to those new environments. I think I'm still happiest in the mountains, but I think once you have a good core fundamental science understanding, you can adapt and evolve. But I'll never go into a new place like that and purport to be an expert on it. I think that's another thing that wasn't on my list of things to remember. But if you don't know, sometimes that's the best thing to say as a scientist or as a human. If you don't know something, don't just wing it. Say, A, I know someone who knows that and I'll get back to you, or B, I can get back to you once I have a better understanding of it. I think the ability to admit that you don't know something right away is one of the most powerful things you can have as a human. Other questions? No one wants to know where some of these fisheries are? That one's behind my cabin in the Sangres, but it's like 20 miles back. So I feel safe that no one's going to catch that fish except me. Well, thanks for your time.
Thank you so much.
Thank you.
I have one more bonus question since we're about out of time, and I know people might be heading out there at the other event, but you mentioned stepping down from your management role. How did you come to find out that you didn't like that skill set and decided to go back? Because I think that's a normal thing as you get promoted out of the fun stuff and into stuff.
I just found myself doing things that I didn't enjoy, you know, and as a scientist, it was challenging too, because you're zooming out and you don't have direct control over the core pieces of science that you're overseeing. And I like getting my hands dirty, not just winging it. That was hard on the Water Quality Control Commission too, is that you were, at least for a time, I was one of the only scientists on that 9-person commission. And so when you were faced with a fundamentally science issue, and I'd only had the same 2 weeks to dig in on it, I felt like imposter syndrome, because like Sakata was looking at me as if I knew the answer from a science standpoint. And so I think that was part of it, is just being too far away from the actual weeds of the science, and I enjoy that. So. And I hate administrative, like the exercises that would come in on a Friday morning, fire drills. It's just like, this is not important. Why am I dealing with this? So.
All right, thank you, Gavin. Burn 400 if anybody's headed to the Navajo Nation water tower.
You hear that?